Hey, what's up everybody, welcome back to another video. It's been a while. So yeah, welcome to a brand new series. I'm going to guide you, or we make the tutorial along with you, making this type of game, character action game. So what is the plan for the series is that I'm going to teach you how to make this movement system using non-root motion animation, and also using root motion animation like this one. The attack is using root motion, and also the setup for the enemy animation and enemy behavior in the future. Right now the enemy doesn't really have any behavior, and the camera system, like the lock-on system, and then the free cam system, if that's a thing. And in the future I will add more like the UI, maybe a little bit of a game design itself, like upgrades and stuff. I don't really know where to take it, so if you have an idea or if you have a request, please leave a comment down below. What do you want to see in the future or to be covered in this series? But yeah, that's gonna be it. Oh, if you want to follow along by downloading the project, you can go to my Ko-fi page, link in the description below. With $5 a month, you can get all the project files from the past for free. So you don't need to pay extra. So you just need to pay $5 and you can download all the Armored Core project, or the hack and slash from the past, or the Hades project file from the past, with only $5 a month, and you can get access to this new new tutorial series early than the YouTube audience. And with that being said, thank you for your support if you already bought something, and thanks for your continued support. There's a little bit of a house cleaning thing, or channel update in that case. So for the first part, I think I'm just gonna talk about the movement system first. Let's break it down and see how I made it. So let's just get into it. All right, so let's talk a little bit about the node setups that I'm implementing here. So basically I have the unit base as a class. Use a little bit of inheritance and composition at the same time. So what is the class name? Is called unit. So unit is the base class for all the units, basically. So the enemy inherit from this unit base node, and also the main character inherit from this unit node also. What does it have, or why do I do that? Because I think if the enemy and the player has a similar, or require similar things like HP, or add it to the groups, or have same signals like this one, I think it's a lot easier to manage, to put it in the same unit or same class in this case. And so yeah, so basically these are the shared variable. It has HP, and then the unit type. Is it an enemy? Is it a player? If it is an enemy, or if it is a player, then you need to add it to group. This will be useful for the lock-on system later on. So you need to add this, or you add the node to the respective group. And also some physics process, like the move and slide, it's all handled here. There is also the gravity system, like pulling down the player, or the units in that case, Yeah, even though I don't really implement the jump mechanic in this game, but maybe in the future. So this is more for future proof. So for now, it doesn't really affect anything. You can actually comment it out, and it works just fine. But at least it will do for now. And then the signal, for example, I have a hurt box that shares with that every unit shares. Every unit has to have a hurt box. This will be different if you have like a boss, for example, with multiple different hurt box. Then maybe you need to create a different unit. But in this case, I want to keep everything simple, so everything is clear. So the hurt box is really simple right now, which is this red cube. And the signal connect to the unit base, and then there you go. If an area entered, if it is a hitbox, then get the hitbox damage, and then if it is a knockdown or not, then yeah. And then if HP smaller than 0 or equal to 0, then emit signal dead, and signify that, hey, I'm dead here. And so that's basically what is shared by the units. Again, this is for organizational purposes. It doesn't, maybe this is not the best practices for every game, but this works at least for clarity purposes and for this simple project that I'm working on. So yes, I know some people will type, oh, but if that's not the optimal way. I know it's not the optimal way, and I think the optimal way is just different for every game and different for every project, even if it is the same genre. But hey, this is just for clarity. This is for education purposes. At least you know the concept. So I need to justify that for a moment. But thanks for the comment though. Some people leave a useful comment, and I will, of course, give a love or a thumbs up here and there. And so yeah, so that's basically the unit or the node setup for the base class. So yeah, now let's take a look a little bit. So this is the enemy. It has the hurt box, and then the hurt box already connected the signal, or the signal of the hurt box already connected. So you don't need to do that over and over again. The main character also share the same thing. So all right, so let's break down the main character after that. Yes. Okay, so let's talk a little bit about the character setups, or the playable character, the player character here. As I told you before, it uses the inheritance. So we right click here, and then you inherited scene, and save this as the main character, and then use that as a base for the main character itself, because it has all the shared variable there. Now, what are the things contained in the main character? Of course, it has the model with the animation system here, and then movement composition, and then attack composition. There's also a timer here for the timing of the dash, like the cooldown. Hurt box, it is inherited, and then camera rig. I'm going to touch one by one on the movement comp, and so on and so forth. So I think let's talk a little bit about the animation tree. So the animation tree setup. Animation tree is not built in, or when you import it, it doesn't really have that. So it doesn't really have that when you import your model. So you need to create it. So basically, that's the control for the for you to use. To control every animation in the animation player, and this is the setup. I hope you're a little bit familiar with it, but so yeah, this is the setups, and I'm using tree root is the node blend tree, not the state machine, because I think it's just a lot easier to organize. It's a lot, I don't know, it's less cluttered, I guess. That's what I'm trying to say. And so yeah, let's ignore all this one, but let's take a look at this main transition here, or the main states. In this case, I name it state. It has base, attack, and dash. So that's kind of like the main state. You can add like death, for example. My philosophy in this case is that if you think that one thing will override the other, then you make a new state. For example, the attack will override the movement, right? So you make a different state, and dash will override the movement and the attack, and attack can also override the dash. Then you need to make a new state, like death, for example. Then you need to add another state here. So that's the philosophy of adding transition or state in this case. Does that make sense? But yeah, that makes sense to me in my head. But so that's basically the idea here. The base movement is just contain like the idle and then the running animation. And one thing that you need to know, the running animation doesn't really have any root motion. So the animation itself doesn't really move around. So it's just kind of like running in place. While the attack, actually, they do have root motion, but in this case, it doesn't show because already set up in root motion. I will cover the root motion part of things later in different video, I think. So let's talk about the movement composition and what does it do. Let's break it down. So this is what contains in the movement composition. It has dash timer. This is the one that control how often the player can dash. And so yeah, so basically that's the idea of the timer itself. Did I just speak there? But anyway, so what am I going to talk about? I forgot. But yeah, so these are the variable that is needed by the movement system itself. But like I told you in the opening, the gravity and jump force is not really used. It's there for future proof. So just in case I want to add jump in the future, jump mechanic in the future, you can just go straight into it. And then there is references to the camera, because the movement type to the camera. And so yeah, that's why you need the reference to the camera. And then this one, the internal parent body, is this is because the composition nested in the base node, in the unit node, then it needs the reference to the what is it, to the parent node in this case, and just say parent body, because the movement will control the parent velocity. So yeah, and then the direction, this is just to see which direction is the final direction or the camera direction. You can see it later, is dashing or not. This is just checking if the player is dashing or not, but I think we can ignore this one because the state checking is done through the check of the animation tree itself. So all right, break down the physics process here. Current state, this is a built-in or a new variable created just to check whether which animation is being played or which state is the animation currently in. When I said state, I'm talking about this state. Is it in the base, attack, or dash? If it is in the base, so if the player can move freely, basically, then execute the movement delta. If it's not, if it is in attack or dash, then you use root motion for the extracted from the animation that is being played, and then set the velocity to the root motion velocity or movement itself, and then rotate it with the rotation of the body. Again, I will dive that later on. And then dash if you want. Yeah, and then dash is just like, hey, I can dash. And then this is the what is it? The function or the method to execute the dash. Okay, let's talk a little bit about the movement execution here. So again, so check whether the current state of the animation is in base. If it is based, then you move. Basically, that's kind of like the idea, and the movement itself is executed through this code. So let me show you what the movement exactly, what does it do? So when you push forward, it will always move forward towards where the camera is pointing, right? If it is backwards, then it will go towards the closer to the camera, I guess, is if when you forward, it's move far away from the camera. And left is always go to the left side of the camera, right always go to the right side of the camera. And when you rotate, it will always do the same. So that's kind of like the idea of the movement system itself. So let's see how it's being executed in the code itself. Yeah, I think it's fine. And so what we have here is that the reference to the camera, check whether the camera exists or not. If it exists, then use this, execute this code or these lines. And then if it does not, then move back to or fall back to this when there's no camera, right? Or basically this is using the basis of the model itself or the composition itself. Now, so if there's a camera, then we need to get the basis of the camera. So basis is basically to get the transformation of the where it's pointing at. That's kind of like the idea. If you want to read the document, there's the documentation on it, and it has a great tutorial on it, but that's basically the idea. And then get the direction from the basis X and the basis Z of the camera, and then set the direction of the Y and the Y axis to 0, because we don't really want any tilt or any intervention from the vertical axis here on the Y axis. And then you normalize the direction after that. So normalize is just make the value from 0 to 1, or from whatever the value is, and then clamp it or make it into like 0 to 1 range. Maybe that's better. So yeah, so you get the input direction, of course. This is the movement input, and then multiply it with the basis X and then the basis Z. This will return vector 2, or excuse me, vector 3 variable. And so yeah, and now if there is a direction, if basically the player push any movement buttons, then you set the velocity of the unit accordingly to the direction and the speed that is set in the beginning here, or that is established here, which is 8. And yeah, and then the acceleration, of course, how fast it moved from 0 to max speed. And then yeah, that's basically the movement system. And then to rotate the player itself to the direction that is being pushed or that is being manipulated or that is being directed, we get the rotation target here by getting the, what is it, or the transform direction here, the input plus the camera basis, using the direction X and direction Z, and then rotate the, or the check the rotation of the player right now, which way they are pointing at, or rotated in y-axis, and then rotate in y-axis to the target rotation. So this will return an angle, so in radian, and then you just use lerp angle to rotate whichever the target is with this increment every frame, so it makes a smoother smoother rotation. And if there's no input, you just stop the player or deceleration and then move the, or set the velocity to 0 with this step. Excuse me. So that's the movement system itself. Yeah. Well, before I go, I guess let's touch a little bit on the camera setups. I'm going to ignore all the lock-on mechanic. I will talk about it in a different section, but let's talk about the free cam. So free cam is this section or this bit here where there's no lock-on, where the camera is not locked. So you can go like left, right, up, down, and so yeah, let's discuss about that a little bit. Just like the movement system, basically, I get the input from like what is the player doing, also get the cam input and also the directional input. And directional input is useful because, maybe I shouldn't close the game, is useful because when you push left or the player move left, the camera kind of like also pan to the left, and then this one, not panning, I guess, kind of like, yeah, move to the left or rotate to the left, you know, so it's kind of have that feeling of a steering. So it's not just kind of like what is it, stay and then left is just left, not strafing, but it's more like steering, if that makes sense. There's also one of the polish that you can do in your game, but anyway, so get the input, get the camera input, and then rotate the rig. As you might see here, there is the camera is like, the rig is set up like this. It has camera rig and then camera rig X. So the first camera rig is the one that handles the Y rotation. So Y rotation is the one that is going vertical. So you rotate it like this. So, you know, rotate it like that. So it's kind of like handling that, looking left to right, while the X is kind of like the tilt up and down, kind of like, you know. So you need to separate that. And I think you need to make the Y kind of like the main axis or the first node, and then the X is the second one, because it will affect the feeling of the camera rotation. Then after that, if there is an input left and right or in the X axis, which is this one, then you just rotate the rig, the main rig, and then the rig X rotated to the up and down when there is the input of up and down, the camera up or camera down. And then this one is just a reset, basically. If the player hit the camera lock when there is no enemy, the camera will reset. That's kind of like the idea. So, oh, and also I forgot, maybe I need to close it. The camera rig X is a spring arm. So spring arm, what spring arm does is basically it raycasts to a certain point and then check whether if there's collision. If there's collision, then it will push the camera towards the spring arm closer. So for example, like this one, if there's, it's just clip, it doesn't clip, I mean. So when there's a floor, it's like the camera is kind of like push forward. Or when you get to the edge like this, to the wall, and then it will push towards the player. So it's automatically handling those kind of collision problem, so it avoid clipping. And but I want to make sure also that the spring is only interact with the environment. So in this case, the collision mask only collide with the environment. not the player, not the enemy, because if it collides with those, it will just kind of like have those kind of like frantic movement or unexpected movement. Excuse me. So with that being said, I guess that will conclude the first part of the tutorial, and let me know what you think about the tutorial. Do you want more explanation on some parts? I'll gladly have an explanation on that, and I will add more section in the future. And what do you want to see in the future? Let me know in the comment down below. So for now, I guess that's it. My name is Everdengra. See you next time, and bye bye.